In this video, we are going to make the hexagon meshing of this geometry in the workbench mesher or the Ansys meshing software. Okay, so we are done with this geometry part, and also make sure that the analysis type is 2D selected, and then double click on the meshing application here. And this will start the meshing software or the workbench mesher, also known as the Ansys meshing. Okay, so we are inside the meshing software. And here we should be making the few things here. The first of all, that the thickness should be 0. So make sure for all surfaces it should be 0. 0 for every surface inside this part number 2. Second thing is that in the meshing, this should be, the solver should be the fluent and the physics should be CFD. And if you see the mechanical, then just change it to CFD is very important thing. The next thing is that we are going to insert the meshing, and that is first thing is the face meshing. So I'm going to choose these all 6 faces and click on the update. Although the mesh is very coarse, but you can observe that we are able to create this map meshing. The next thing is to set the sizes. So this is very simple thing. So I'm going to first, okay, this is selected by mistake. So first thing is that we should hide these mesh parts, or maybe not required. So first choose the edge command and choose these edges which are here. Okay, so I just deleted the mesh. Right click here and click on clear generated data. So this will remove the mesh from the screen. Okay, so I will be choosing these edges first, and I'm going to put the number of nodes on these edges, on all the edges in fact. We're starting from these edges which are here, and just choose the edges which are parallel to each other. It means that the mesh will go from here to here, and so these nodes will be same on all these edges. And from here I'm going to use the number of divisions, and I'm going to choose 120 and make this option as the hard. And this is very important because hard means that this will implement the things we are going to apply here on our own. And the bias factor I'm going to apply is starting with maybe 500. The bias factor is a ratio of the smallest to the largest element. This is not a ratio you see in the Gambit or in the ICM CFD. It's different than those softwares. So you can see that we have some spacing are placed on this side, some are on the other side. So anything which on the other side should be reverse side should be selected. Also this edge, and this edge. Okay, so now the bias is reversed, and I will just again click on the generate mesh. Okay, so we have the problem of defeaturing. So I will go to the meshing, and from the meshing we have the sizing option, and make the defeaturing size to the point 4 zeros and 1, and again click on generate. Okay, we are not seeing any problem like this again. And you can see that the first cell height is this may not produce a very good white plus, but this is very near to this geometry part here. Okay, the next thing is that I'm just again going to delete this everything from the meshing so that I can see these edges very clearly. Okay, again I'm going to choose this edge. So these are basically the aerofoil, the pressure side and suction side, or the pressure upper and lower side, and click on sizing. I'm going to put the number of nodes equal to the around 100 to 120, and click on generate. So we should be seeing the mesh on the very regular interval. So you can see that this was not implemented. So we have to change this to the hard. and this will implement our meshing requirements. Okay, so with the soft, the solver will select that the okay if the user input is appropriate for the measure or not. So if it thinks that it's not appropriate for the meshing, it will not implement. So, but with the hard, it will implement by any means. Okay, next thing is to again I will clear any data here, and this time I will choose these edges which are here, and you can also select these edges in a group. So you can see this is not parallel to this edge, but we can implement the same number of nodes on these edges because we are going to apply on the leading edge. So leading edge should be having the same nodes on the two sides. Again, I'm going to implement this elements, maybe not more than 12 here, or maybe 15, 16, maybe maximum 20. And again, should be choosing the hard and generate. Okay, so this is the mesh right now in this way. Okay, next thing is the mesh on the downstream side. This is very important mesh. So again, I will be repeating same procedure. And these three edges are selected now. And click on sizing, and the number of elements I'm going to use, they are going to be around maybe 150 or 200. And I'm going to use again the hard behavior, and I'm going to use the biasing also, and the bias factor I'm going to use maybe is the 500. So I will choose the different biasing here. So okay, only this one is making issue, so I will select this in the reverse biased and click on the generate. And you should be checking the mesh again and again so that we can be confirm about the everything is perfectly done. So in this case, I think we should be having the bias factor should be around maybe 2000, and click on generate. Okay, so we have more finer mesh towards this edge, and now we should be working on this edge sizing. So I am going to put the 150, and I'm going to put the biasing also, because we need to have the similar mesh towards this side. So the biasing factor I'm going to use is the, let's say, 500, and simply click on generate. Okay, so we have the bias factor equal to 500 and generate. Okay, you can see that the mesh here is very refined here, so I don't need this much refinement. So I will go with 100, and also I will be using the reverse biasing on the top edge. Okay, so sizing here is almost same. We can go back to this side, and maybe you can change the biasing factor to 2500 so that we can see the same mesh on the both sides. Okay, this is okay. But here the mesh is very different. So what I'm going to do is that for these edges, which is on the top and the bottom side of the aerofoil. So let me choose these edges. So I think this is here. Okay, so I'm just going to make the biasing on the two sides, which is like this one. Okay. Or maybe only this one. Okay, let me try again. Okay, finally I chose the number of deviance 250 for these edges, and the behavior is the soft, and the bias factor is 30. And now you can see that the how this mesh will look like from the interior. So we have the smooth transition between these two blocks, but definitely we have the size change between these two lines. And I recommend that this line should be inclined up to this angle. So you can go back to design modeler, and the inclination of this line you can make from, instead of this line, up to here. This will solve this problem very much. So this is my recommendation, that you can go back anytime into design modeler, just make this angle. So this will solve this very large element size between these two blocks on the outer side of the domain. Okay, so we are done with the meshing part here. So the next part is in the fluent.